Hello and welcome back to the DAM. Today's video will be about 30-pin memory SIMMs. I got the idea for this project back in 2023 when I bought this motherboard. It's the FIC 486-VC-H from 1993. This is the motherboard that we repaired in a previous video, and I will leave a link to the video down in the description. So if you haven't seen it, you can go and check it out. When I found this motherboard on eBay back in 2023, the first thing I did was to check out the retro web page for this motherboard to see some specs and yeah, just to get some more information about it before I decided whether to buy it or not. What caught my attention back then was the fact that this motherboard uses 30-pin SIMMs, but also supports a maximum RAM size of 128 megabytes. Back in 1992, when this motherboard was released, most 486 motherboards would support a maximum of 32 or maybe 64 megabytes. So to have support for 128 megabytes is a bit unusual, but not totally uncommon. So the maximum RAM size of 128 megabytes was the deciding factor for me to go ahead and buy this card on eBay. Let's also have a look at the documentation for this motherboard. And here we can see also that this board supports a maximum onboard DRAM size of 128 megabytes. Here we can also see that the maximum of 128 megabytes is reached by having 4 sticks of 16 megabytes in bank 0 and 4 sticks of 16 megabytes in bank 1. After having convinced myself that I simply need a 486 with 128 megabytes of 30-pin SIMM memory, the hunt for the 16 megabyte SIMM sticks could begin. And first off, I had a look at eBay, and I quickly realized that 16 megabyte sticks is not a very common thing. So I quickly came to the conclusion that eBay was not the solution. After having abandoned the idea of buying some 16 meg sticks on eBay, I started looking around on Google for maybe a solution where I could make my own memories. And first up, I found this project by Upload Geek. He has designed a PCB for 30-pin SIMM memory, and let's have a look at it on the Gerber viewer on PCBWay. And here we can see the design, but unfortunately it's a design for a 4 megabyte SIMM, and since we need a 16 megabyte SIMM, this design is really not suited for our project. So let's keep on looking. Next up, I found this project, It's the SIMM RAM by Rick Red. It's a open source PCB for a 30-pin 16 megabyte SIMM memory module. And I think this project is just what we need. Let's start by having a look at the design itself. Here we can see the front of the PCB, where we have first a switch for FPM or EDO memory. Then we have two pads for the memory chips, bit 0 to 3 and 4 to 7. So this is obviously using 16 megabyte chips with 4 bits each. And on the right we have a voltage regulator to regulate the standard 5 volt down to 3.3 for the chips. Now let's have a look at the supported RAM chips. And here we can see that we have 4 validated chips under the 3.3 volt, and we have 3 chips under the 5 volt option, but it seems like they have not been tested or validated. Before we choose which chip we want to use from the list of supported memory chips, I thought we should maybe have a look at a datasheet for an OEM memory stick, an OEM 30-pin SIMM. This one is from Micron, and here we can see that it uses a single 5 volt power supply. It has 2 timing options, 60 and 70 nanoseconds. And if we go further down, we can see here that the supply voltage should be at a maximum of 5.5 volts, and here we have the logic levels, and logic high should be between 2.4 and VCC plus 1. So that would mean between 2.4 and 6.5 volts, and input low should be between -1 and plus 0.8. And the output levels will be between minimum of 2.4 and low a maximum of 0.4 volts. And we have some current ratings. Down here we have some timing requirements, and yeah, I think that's it. I think that's what we need. Yeah, so we should know that the supply voltage will be between 4.5 and 5.5, and the high will be between 2.4 and 6.6, and low will be between -1 and plus 0.8. Next up, let's take a look at the specifications for the recommended memory chip. And let's see, I have the datasheet right here, and it's again from Micron, and it's the 3.3 volt chip, like mentioned over on the page for the project, and let's just scroll down to characteristics, and we can see we need a maximum of 3.3 volts, and that's why we have this the regulator on the PCB to regulate down the 5 volt to a maximum of 3.6 volt. But so that's fine. But next up we have the logic levels, and this is where we run into problems. As you can see, the maximum logic high is VCC plus 0.3. So that would mean that this memory chip can accept a maximum of 3.9 on the data pins and a minimum of -1. And that's actually a problem, because if we go back and have a look at the design, we can see that we only have one regulator on this PCB, and that is for the power supply. That is not regulating the data lines. So they will still be at 5 volts when coming from the motherboard. And as we can see here for the datasheet for this chip, it cannot handle 5 volts on the data line. It only goes to 3.9 volts. So yeah, I actually don't quite understand why or how this could be preferred, tested, and validated, because as I see it, this design would be operating these chips out of spec and putting way too high a voltage on the data lines. And actually, if we look at the OEM chip, they could put up to 6.5 volts on the data line, and these chips only can handle up to 3.9. So yeah, I don't think I will go with the 3 volt chips. So let's have a look at the datasheet for one of the 5 volt chips. Here we have the datasheet for the first of the 3 listed 5 volt memory chips that is compatible with this project. This datasheet covers 2 variants of this memory chip, the 8-bit and the 4-bit variant. And as we saw in the picture of the PCB, we need the 4-bit memory chips. So what we're looking for is the KM44C16100B chip. And if we compare the datasheet for the OEM chip and compare it to the KM44C16100B, we can see that the maximum voltage rating on both chips are -1 to +7. The storage temperature, it's not really relevant, but it is also a match. And if we look at the logic levels, we can see that both chips expect a minimum of 2.4 and a maximum of 6.5 volts for the high level, and -1 to +0.8 for the low level. So all in all, I think this chip is a good match for our project. And yeah, I'm not gonna investigate any further. Let's just go with this chip. I will put in an order for, I don't know, maybe 100 of them, and let's move on to the PCB design. And here we have 3 different designs for the PCB. The one we will be using is the one on the bottom for the 16 megabytes, but I would like to make some changes to that design. There is a number of things that I really don't like about it, but they are minor things, but I feel that they should be corrected. The first thing I would like to change is the fingers, as we can see on the OEM stick from Samsung, and also on the 4 megabyte SIMM from Uplate Geek. We have square fingers, but for some reason on the SIMM 16 we have fingers that are at least they're not square. I don't know what to call that shape, but I would like to have square fingers as on the OEM board. So that's the first thing I would like to change. Next up, I would like to remove this switch functionality, where you can switch between EDO and FPM memory. We really don't need that functionality, since the memory chips that we have chosen is FPM only. We can also go ahead and remove this voltage regulator, since we have gone with 5-volt chips. We don't need the regulation for 3.3 volt. And the final adjustment to this design we will make is to remove this cat, because as we all know, a cat on a memory stick will greatly reduce the performance. Instead, we will add a nice and golden shiny beaver to this PCB, and that will ensure that we get the maximum performance out of this memory. And we are now back on the bench, and I have just sent off our new PCB design to manufacturing. Our manufacturer for today will be PCBWay. They are also the No, they're not. I don't have a sponsor. These PCBs I will buy with my own money, but I like. I really like the products that I get from PCBWay. So I will highly recommend that if you ever need to have a PCB manufactured, take a look at PCBWay. But for now, we will just have to wait and see what we get when my order arrives. And through the magic of YouTube, we have now received our PCBs from PCBWay. So let's go ahead and unbox this thing and see how they look. A bit of foam padding, a receipt, and here we have our new shiny RAM sticks. Let's close the box, get that out of the way, and let's open this package. And let's get this everything opened. Cut it down the center. Let's see if we can get into this bubble wrap. I am no professional YouTube unboxer, as you can see, but here they are, and wow, they look quite good, I would say. But let me give you a close-up. Here you can see the final result from our PCB design rework, and you can see how they turned out. I have ordered these with the gold flashing on top, so they are nice and shiny looking, and of course we have the golden beaver that will ensure the performance of these memory sticks. And with the PCBs ready, we can move back to the bench and try to assemble some of them. And that is one memory stick done. Let's have a look under the microscope and see how our stencil-less method worked. And let's see if we have a good connection on all the pins, and I would say so far it is looking pretty decent. That side is okay. Let's flip around the module and check the other side. And the pins on this side also appears to be all connected. So that is one stick done. Now we just need to make 7 more, and then we will have our full 128 megabytes. And just like that, we have a full 128 megabytes of 30-pin SIMM memory. So now for the exciting part, putting them in our motherboard and see if they work. So that we will do next. Everything has now been hooked up. We have our 128 megs of memory installed, power, VGA, postcode analyzer, and controller card. So fingers crossed. Let's do the first power on with our new memory. And yeah, this is I'm a bit nervous. If this is not working, it will have been a lot of work for nothing. So yeah, let's power on. And 3, 2, 1. Come on. Oh, this is looking good. Yes, it is. It looks like it's working. That is amazing. Wow. Let's just hit delete for setup. 130 megs. Wow. It's just... And damn it. The system just froze. Let's power it off and power it on again. Let's hope this was just a fluke. I really like the sound of the system counting up all that memory. But maybe it's just me. I don't know. Let me know if in the comment if you know if you also like this sound of memory being counted up. And come on. The system froze again. Damn it. Let's power off and power on again one last time. Okay, let's give it some time. Maybe it just needs some time to boot. And I have now been waiting like I think 2 minutes and nothing is happening. So let's let me just think about it and come up with a plan from here. And I have now come up with a new plan for this project. And let me introduce you to my known good 486 motherboard. It has only 4 sockets for 30-pin memory, but I thought maybe we will just test out 64 megs at a time and just make sure that the problem is not the memories, but maybe more likely it is a problem with this motherboard. But yeah, let me install 64 megs on this board and we will test it out. Everything is now hooked up, and I have also set my Gotek to boot the Mentest boot disk. So hopefully this will work. But let me just go to my capture card, and we are ready to boot in 3, 2, 1. And okay, this has at least detected the memory. 64 megs. Let's hope this will not freeze the system. Okay, this is looking promising. Okay, we have our 64 megs detected, and it is running the tests. So yeah, okay. Let me just adjust this picture a little bit, maybe. I mean, yeah, it's looking fine. No errors, and the system is not hanging up. So I think these memory sticks are okay, but I will not let this run until the end, because it will take a very long time for this 486 to test 64 megs. But let's just power off and plug in the other 64 megs. And as you can see, the next 4 sticks of memory also seems to work fine in this board at least. So I think I can conclude that the problem is not caused by the memory stick, but more likely the motherboard. So let me look in my stash of motherboards and see if I have a motherboard that will support 128 megabytes. And as you can see, the next 4 sticks of memory also seems to work just fine in this board at least. So I think I think we can conclude that the problem we are having is not caused by the memory sticks, but more likely the motherboard. So let me look in my stash of motherboards and see if I have another motherboard that will support 128 megabytes. I have now checked my collection of motherboards, and unfortunately I don't have any 486 motherboards that is listed on the retro web as supporting 128 megabytes of 30-pin SIMM. But I did find this motherboard, and that is the ABit AB-AN4 in revision 1. And as we can see, this supports 64 megabytes and not the full 128 megabytes. But looking a bit more on the retro web, I've discovered that this motherboard also comes in a slightly different variant, AB-AN4T revision 2, and this motherboard supports 128 megabytes. And as we can see, it has the exact same chipset as the revision 1 motherboard that I have. So I think maybe this will work with 128 megabytes, even though it's listed as 64. So let's get this motherboard on the bench and test it out with 128 megabytes. And I have now set up the ABit motherboard with 128 megabytes of memory, and I don't have high hopes for this to work, since this motherboard is listed on the retro web for to support only 64 megs. And if this does not work, we might have to maybe we can do a BIOS swap and take the BIOS from the card that supports 128 megs and use that in our system. But yeah, let's first test out this setup and see if we can even boot it up. As you can see, we are now booted into a memtest, and on the boot up we could see that it detected 128 megabytes, but for some reason memtest is only detecting 65 megs. That that could have something to do with this motherboard not supporting more than 64 megs. But let's go into, we can go into the configuration menu, and maybe we can force it to use 128 megs. Let's choose the probe option, and yeah, it has detected the full 128 megabytes. So this is looking very promising. I will let this. I think I will let this test run all the way to 100%. We can then see if we have any errors on the memory, or if this is actually fully functional. So let's just wait for this to finish. As you can see from the 12 hours of memtest 86, this ABit motherboard is fully functional with our 128 megs of 30-pin SIMM memory. Next up, I would like to do some more performance testing of these memory sticks, but I think that will have to wait for another video. This video has been going on for long enough now, I think. So the final thing we will do today is to do a final conclusion. And the first conclusion we can draw from this is that yes, it is definitely possible to have 128 megabytes of 30-pin SIMM memory in a 486. So that is good to know. And the second conclusion will be that the information on the retro web is not always accurate. This motherboard was listed as supporting a maximum of 64 megs, but from our successful MEM test, we can see that this board supports at least 128 megs. So maybe I have some more motherboards that we can test out in the future that is listed for only 64 megs, and we can see if some of them also will support 128 megabytes. And lastly, we can conclude that this thick motherboard that we repaired in a previous video is definitely not 100% functional, since it keeps freezing up when we plug in our 64 or 128 megabytes of memory. So yeah, maybe we will have another look at this motherboard in a future video. Anyway, this is all I have for you today. I hope you enjoyed this video about memories, and if you did, don't forget to hit the like button, and if you would like to see more videos about these memories, you can also hit the subscribe button, and I will show more of these memories in upcoming videos. In any case, that is it for today, and I will see you in the next video.